Welcome to this explainer. Okay, let's just dive right into it. When we think of winemaking, we usually picture these romantic, sun-drenched vineyards, maybe some rustic wooden barrels in a dark cellar. But behind that picture-perfect bottle sitting on your dinner table, well, there is actually a fascinating, highly technical world of microscopic chemistry at play. Today, we're unpacking what we call the crystal conundrum, and we're going to look at exactly what winemakers do behind the scenes to make sure your favorite glass of wine looks absolutely crystal clear.
So, you know the feeling. You've reached the very bottom of a really delicious bottle of wine. You go to pour those last few drops, and suddenly you notice what looks suspiciously like coarse sand or even broken glass just settling at the bottom. Or, maybe you've pulled a cork and found this crust of hard, crunchy crystals clinging right to the bottom of it. We have all had that momentary visual shock. It immediately makes you wonder, right? Like, did something go wrong with the wine? Is it spoiled? Is it even safe to drink? Well, the absolute most crucial thing to know here is that these are completely 100% harmless. In the industry, they actually call them wine diamonds. Scientifically speaking, they are potassium bitartrate crystals, or just tartrates. Now, when the grape juice, the must, is warm, these are totally soluble compounds. They dissolve perfectly. But because the potassium mixes with natural tartaric acid during winemaking, any sudden drop in temperature causes them to literally precipitate right out of the liquid and form those solid crystals. It's just a completely natural byproduct of the wine's own chemistry. To really get to the bottom of this, we need to see where the potassium comes from in the first place. Section 1. Potassium in wine, from soil to vine.
You see, potassium isn't some sort of accidental contaminant. It's an absolute essential macronutrient for the grapevine itself. The whole journey starts with soil absorption, where the roots pull in potassium ions from the earth. Next up is root translocation, which just means moving those ions up through the plant to help with enzyme activation and keeping the plant healthy. Then, as the grapes actually develop, the potassium travels straight into the clusters to help them grow. Finally, the big moment, fermentation release. When those grapes are crushed and fermented, the plant cells burst wide open, dumping all that dissolved potassium straight into the must. And that alters the pH and completely sets the stage for our wine diamonds to form later on. So, knowing where it all originates, let's jump into section 2, winemaker solutions for achieving stability.
What's genuinely fascinating is how the wine industry actually handles this massive potassium overload without completely destroying the wine's natural, beautiful flavor. Winemakers basically fall into two different camps. On one side, you've got physical precipitation. That means physically forcing the crystals out of the liquid or filtering out the ions, using heavy-duty methods like cold treatment or reverse osmosis. On the exact opposite side, you have chemical inhibition. This relies on microscopic chemistry, using highly advanced additives like polyaspartate or CMC to basically stop the crystals from ever forming in the first place. Let's start with the classic, old-school physical approach. Section 3. Cold treatment, inducing precipitation. The concept here is beautifully simple, really. It basically just mimics what happens naturally to wine when you leave it in a really cold climate. Winemakers will dramatically chill the wine down, and we're talking down to between -4 and -2 degrees Celsius. That pushes the wine to just barely above its freezing point. By holding it at that extreme chill for several days, the liquid's solubility plummets. This forces all those tartrates, plus some other unwanted stuff like certain proteins, to crystallize and just drop right to the bottom of the tank. Once it all settles, they just easily filter the crystal clear wine right off the top. It is incredibly effective for visual clarity. But what if you can't just freeze massive tanks of wine? That brings us to section 4, chelation exchange, swapping the ionic balance. Right, so if a winery wants to skip the extreme chill, they can use cationic exchange to tweak the wine's actual ionic balance. And this is practically a microscopic tag team match. The wine flows through these specialized ion exchange resins, which are chemically designed to attract specific ions based on their size and charge. They specifically target and grab those problematic potassium ions, pull them out of the wine, and instantly swap them out for much friendlier ions, like sodium. It completely neutralizes the crystal threat while carefully protecting all those delicate aromas and flavors we want to keep. For even more precise control, winemakers turn to high-end physics. Section 5, reverse osmosis, our high-tech filtration. Reverse osmosis is basically the ultra-strict bouncer of the microscopic wine world. The system runs on a few main components. After a quick pre-treatment to catch the big sediments, a super high-pressure pump literally forces the wine through a tightly wound, semipermeable membrane module.
This membrane is incredibly picky. It lets the wine pass through, but entirely traps the larger solutes, the unwanted potassium ions, and even excess alcohol. It's a seriously versatile tool. Not only does it stop tartrate buildup, but winemakers can use it to precisely dial in the alcohol content and flavor profile without stripping the wine's soul.
Let's step away from the heavy machinery for a minute. Section 6. Chemical stabilizers. Exploring high-tech inhibition.
So instead of trying to physically drag the potassium out of the wine, winemakers can actually just drop in molecular shields to freeze the whole crystallization process in its tracks. First, there's potassium polyaspartate. It's fairly new to the scene, acting as a natural chelator that blocks the actual nucleation, literally preventing the birth of the crystal. Then we have carboxymethyl cellulose, or CMC, which basically wraps itself around any tiny crystals that do form and stops them from growing any bigger. Finally, metatartaric acid converts bitartrates into shapes that just really don't want to precipitate out. These keep the wine flawlessly clear without losing any of its complex texture.
Okay, quick fun fact for you. This completely blew my mind. Carboxymethyl cellulose, that water-soluble plant polymer that acts as a molecular shield in your wine, is the exact same additive the food industry uses for frozen desserts. Seriously? The exact same compound keeping those crunchy wine diamonds out of your Friday night Cabernet is also working overtime to prevent nasty ice crystals from ruining your favorite sorbet or ice cream. It keeps them perfectly smooth and creamy. Talk about a masterclass in texture control across two completely different industries. So why does all this matter when you're just standing in the store picking a bottle? Section 7. The balancing act of choosing a method.
Every single winemaker faces this ultimate dilemma, and they really have to choose their weapons carefully. Do they go with cold treatment? It undeniably improves overall clarity, but it eats up massive amounts of time and energy. Do they shell out for reverse osmosis to perfectly preserve the taste and smell, despite the huge equipment costs? Or do they opt for chemical additives for highly efficient molecular inhibition, which completely avoids the actual liquid loss you get with heavy filtering? It is a constant juggling act. Their choice depends on the grape, the climate, and the specific style of wine, always trying to balance that flawless visual appeal with the actual structure of the drink. Which brings us to the biggest question of all. Is absolute, flawless visual perfection in a wine really worth the risk of stripping away some of its natural raw character? The next time you pour yourself a glass, I highly encourage you to consider the insane journey, the complex chemistry, and all the scientific intervention it took just to make that liquid perfectly clear. And hey, if you ever do spot one of those little wine diamonds sparkling at the bottom of your glass, maybe ask yourself, is that actually a flaw, or is it just beautiful proof of life from the vineyard? Thanks so much for joining me for this explainer, and keep questioning the science behind the things you love.